I'm doing a series of videos on purely academic subjects because academia has an interesting characteristic compared to fearmongers and liars. They're literally immune to neener neener. If any point source emits in all directions about that source any form of emission, doesn't matter what kind, does the intensity decrease with distance from the source if it goes in all directions equally or not? And is this because of its spread over a greater area as the distance increases, or does this inverse square law only apply in a perfect vacuum? If you get twice as far away from something, the total amount of whatever it is decreases by down to a quarter of what it would be at a certain distance. This is a ratio only thing. It's like decibels. Decibels are not referenced to anything. There's no such thing as a reference point for absolute 1 decibel. I mean, there is, but we don't really use that. The ratio is the decibel rating, and this is the same concept. The further you get away from something, the lower intensity from that source will be, unless, but only if it's going in every direction at once and it's a pinpoint source. If it's larger than a pinpoint, it could have variations to it. It could have a surface that blocks itself. It could be in a canister. But we can't assume anything about our source. We have to consider it a point source, an omnidirectional point source, etc. If we do that, is the inverse square rule correct? And does it only work in a perfect vacuum? Or does it work, or is it more dominant, even in certain materials? Now, I'm going to bring this up quickly. Does this only apply to, does this also apply to gamma radiation, because it's not absorbed by air? Like radio signals, it is absorbed, but it's not dominated by absorption. It's an electromagnetic spectrum thing. Also, a gamma ray can be produced like an X-ray can be produced, technically from non-nuclear reactions. It's technically possible. You can have some material that does have the ability to emit gamma rays. It doesn't have to be a radiation source. Do alpha and beta particles, as they ionize through the air, do they travel far enough for the inverse square law to apply over any distance at all, or is that absorption ratio dominant? Or does it simply demonstrate the same inverse square law, but it's a dominant version of it because also absorption over distance? Does any random event produced radiation, any radiation produced from a randomized event, have equal probability in all directions if it's a point source only, or can it be a lump source or bulk source? This is presuming that all of the material is at least of the same material. And does this only apply under certain special cases? Are Kevin Blanch and Dana Durnford's definitions of the inverse square law and radiation, and also their fanboy base, consistent with each other and with reality under observation? Or is this a special case only for Fukushima radiation being some magical sort of radiation that does not obey laws of physics? And am I misinterpreting this? Will any of you evaluate this? Now, this is the funny part about this. This isn't just going to attract Fukushima fearmongers. This is going to attract academics who do not want to get involved in this because they know what it's like to state something factually and have a bunch of people show up saying aliens in their comment section and drive them up the walls. Welcome to the real world of education, all of you out there who are academics. Stop making it just academic. Stop just answering questions or just asking them. Educate. I'm requesting this, and if any of you out there want to do this, don't respond to me. Don't take this as a challenge you have to hashtag. Post a video stating Fukushima is not a special case for radiation. That it is not homeopathy, that the further away it is, the more intense it is. The assertion is based on a special wording someone found in a physics paper, so I'll include it in the title of the video. Does that apply? And obviously, ionizing radiation is radiation that causes ionization as it travels through space. That means, by definition, it loses some energy through ionization. Highly energized particles, or waves, will still have plenty of energy at a distance. And does this violate the inverse square rule as a dominant characteristic, or is it non-dominant? Thank you very much. Have a good day. Good luck.